131 should be just about done. We're going to have Mario get us started since it looks like he's already completely done. So we're going to start with number 1, graph f of x equals x cubed. So give me points, Mario. -1, 1. No, that's not for that one. Try again. How about -1, -1? Okay, there you go. -1, -1, 0, 0, and 1, 1. So that, look up please, that parent function looks like this. However, look up please, they only want the graph from -1 of x to +1 of x. So what does that mean, Mr. Q? That means that you need to erase everything up to those points of 1 and -1 of x. That's all they want to see. All right, before Mariah leaves, she's going to help us with number 2. So Mariah, it looks like this is a circle, which means we need a center and a radius. What is our center? 5, 2. And our radius? 3, or take square root of 9. That is correct. So 5, we got 1, 2, 3, 4, 5. 2 up, 1, 2. And the radius is 3, so we go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and 3. There you go. Thank you, Mariah. Pass someone. Kelly, number 3. This one says g of x equals x squared plus 3. So that means we take x squared and move it in which direction? It would be to the right if it was in parentheses, but it's not in parentheses. We go what? Up 3. That is correct. So that means we're going to take the points -1, 1, 0, 0, 1, 1, because that's the domain they want us to use, and move that up 3 steps. 1, 2, 3. There it is. And number 4. It's an exponential. 2 to the x, and then at the end -3. So 2 to the x is right here. It's at 0, 1, and 1, 2. This is the original one. But they only want us to use the domain 0, 2. So it's 0 to 2. So it would be 2, 4. 1, 2, 3, 4. However, what does this tell us to do? Tell your neighbor, and then Gabriel is going to enlighten us. What does that tell us to do to that original function? All right, Gabriel. 3 to the right, it would be correct if it was on the exponent, like right there. But it's not on the exponent. It's on next to the exponent. So we go 3 to the down. Yes, that is correct. 1, 2, 3. 1, 2, 3. 1, 2, 3. There it is. Last but not least, number 5, tangent angle B. Tangent being opposite over adjacent. Gabriel, pass someone. Sebastian. So tangent angle B, you said opposite over adjacent, opposite being 4, adjacent being 3, so this is 4 over 3. Hands if you got that by yourself. All right, good. Copy the agenda, please. Warm up 131 done. Transformation of functions, and we're down to our last project of the school year. Let's go. We're going to be using Desmos towards the end, not right now. As soon as you're done copying the agenda, come back here and grab one graph paper from the back, please. VXU. Today's presentation code is HGVXU. All right, so we've come to a full circle, guys, in regards to different functions that we presented throughout the year. So this week, I want to make sure that we master all transformations of functions. And taking you back in time, let's see, going way back in your brain, what is a function? Think about it. What is a function? All right, talk it over to your neighbor. What is a function? See if you remember. A function. What is it? Function. Let's see. What is a function? Who haven't we picked in a while? How about Joseph? Function. What is a function? Very good. He said for every input, there's one output. That is correct. And we've seen different types of functions. So just to recap before we get started with some of the transformations, we started off with a parent function. Look up to the screen. Don't copy this. F of x equals x. That's a linear. Yes? And if it has a negative in front of it, what does it do? It goes downward. And you're just paying attention. F of x equals x squared. It's a quadratic. Same thing, if we put a little negative in front of it, what does it do? It does the inverse. And just so that you know, some of you on the final, you forgot about these negatives in front of the function. That's why you got some of those problems incorrect. I'm going to be posting grade probably this afternoon. X cubed looks like this. However, if we put a little negative in front of it, it flips. Is that correct? Downward. F of x equals x to the fourth. Same thing. Negative. Something like that. From there we went to rationals. 1 over x. Like this and like this. However, if we put a negative in front of it, it should look like this and like this. Is that correct? Yes, Mr. Q. From there, we went to f of x equals 1 over x squared. When it has a squared on the denominator, the graph, it's here and here. Is that correct? However, if it has a negative in front of it, what happens to the entire graph? Mario? Yes, it changes, it flips. How about f of x equals, I'm going to give you a parent function for the circle. Like that. Should look like this. Look up. If we set it equal to a number, it should be somewhere right here. And so on and so forth. So, those are the different functions. So, get your graph paper in front of you. I want you to graph me f of x equals x squared. You don't need a table. By now you should know what 5 points to use. All right, turn to your neighbor, let them know the 5 points that you used. Then Enrique is going to enlighten us. 5 points. All right, Enrique, go. Enrique, are you here? Oh, there you go. 5 points. -2 and 4. What else? -1, 1. Continue, Gio, help him out. 2, 4. All right. Hands, if you got that. All right. However, look up, please. What if I did this? Look up. I put a little bracket, and I said -1 less than or equal to x less than or equal to 2. Write that right next to that. So what does that mean, Mr. Q? That means that I want to see this graph. Look up. This that we just graphed, but I only want to see it through this window. What x values, tell your neighbor, between what x values do you want to see only? What x values? Elijah, from what x values? From -1 all the way to 2, because there's the x. That means this is known as the domain. So, let's go to -1 of x. -1 is right here. So, I'm going to do a little highlight going this way. And +2 of x is over here. So that means I only want to see this part. So I highlight that part. And there it is. That function only at that length. Okay. How we doing? Pretty good, yeah? However, what if I said this? Take the parent function, the 5 original points, and I want you to move it 5 to the left and 3 up. Before you move it, tell your neighbor what to write in here and out here. 5 to the left and 3 up. 5 to the left and 3 up. All right, show your neighbor what to write. Then Ashlyn's going to enlighten us. 5 to the left, 3 up. All right, Ashlyn, what do I write? +5 and +3 outside. So that means we're going to take 1, 2, 3, 4, 5 points, move them 5 to the left and 3 up. So I'm going to start with this one. 1, 2, 3, 4, 5. 1, 2, 3. This one. 1, 2, 3, 4, 5. 1, 2, 3. This one. 1, 2, 3, 4, 5. 1, 2, 3. That one. And that one. How we doing? Pretty good? All right. However, look up to the screen. Notice that the original one, they gave us a little window. What was that window? From -1 of x all the way to 2 of x. So that means this point, this point, this point, and this point only. So, in order for me to see that here, what would be my new domain for this one. Talk with your neighbor between what x values so that we only see that little window. Between what x values? All right. Edwin, between what x values? Negative 1 is way over here. It's not even on this graph. Negative 6. And what? Negative 3. Hands, if you got that? That is correct. Between negative 6 and negative 3, it's that same window, so it's here, 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 and here, and that's the only thing that we are going to see. All right. Go to the next one. Example Super Q. Go to the next coordinate plane, and I want you to graph me f of x equals x cubed. But once again, I only want to see negative 1 less than or equal to x less than or equal to 1. From negative 1 to 1. All right, show your neighbor. See what they did. From negative 1 to 1. All right. Give some points, please. Kelly, go. Negative 1, negative 1. Uh-huh. Yes. There it is. Hands if you got that. All right. Next. Look up, please. G of x equals parentheses x blank cubed blank. I want you to move this little piece. I want you to move it 6 to the right and 4 down. 6 to the right and 4 down. 6 to the right and 4 down. All right. Tell your neighbor what to write for your transformation before you move it. 6 to the right, 4 down. Kelly, pass someone. Negative 6. Minus. What? 6 to the right and how many down, everyone? Okay. So we go 6 to the right, 4 down. 1, 2, 3, 4. 6 to the right, 4 down. 6 to the right, 4 down. However, since we're just seeing that little component without the arrows, tell your neighbor the new domain for that little piece. What's the new domain? From where to where? All right, Mario, pass someone. Enrique, what do I write? Between what x values? Well, he's about to answer. This one, the original one, was from negative 1 of x to positive 1 of x. So, that one is between what? We're still in the x. 5. Let's check. Here's 5. Yep, so far so good. And then the other end, 7. Looks about right. And that's my new domain. Hands if you got something like that. All right, not bad. Next. Let's go to the next one. Example Mega-Q. We got, I want you to graph me actually, I'm going to help you with this one. Let's do this. X squared plus y squared equals 1. So this is the function of a circle, which means we need a center and we need a radius. So tell your neighbor what the center is. Are there any numbers next to x and next to y? No, so the center is what? Mario. 0, 0, that is correct. And the radius, how do we find the radius, Mario? Yeah, take the square root of 1, and that is 1. That is correct. 1 to the right, to the left, up and down. And there's our original circle. However, what if I wanted to move that let's move it 4 to the left, 5 up, 4 to the left, 5 up, 4 to the left, 5 up, and a radius of 2. 4 to the left, 5 up, radius of 2. So, tell your neighbor the function, the new function, 4 to the left, 5 up, and the radius of 2. And then go ahead and graph it after you show that to your neighbor. And let's go to the other side of the room. We're going to see if, let's go with Annette. Annette. 4 to the left, 5 up. What do I write? What is it? Plus 4. Minus 5. And then radius of 2. That means this has to be what? 4. Let's double check. Our center is at -4, 5. And the radius is square root of 4, which is 2. -4, 5. Radius of 2 on all directions. That is correct. How are we doing? Pretty good? Yes? Now, before I move on to the last one that we do together, look up. We started with x squared, and we got these. Question. What would happen to this blue one, look up, if I did this? Tell your neighbor, what would happen to that blue one if I did that? Annette, pass someone. Who? Oh, Abby, what's going to happen to this blue one if we did this? What is it? You flip. That is correct. So instead of here, it's here, 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 and there. All right. Look at this one. Look up to the screen. Again, I started with a parent function, but what if I did this to the transformation? Tell your neighbor what happens there. Talk to your neighbor. What happens there to that end product? All right, Renzo, what happens? When there's a negative in the front, it flips, yeah. So this one stays there, but this one flips up, this one flips down, and it looks something like that. So far so good, yes? All right. And the last one. F of x equals 1 over x squared. Let's graph this one together. First of all, we need a VA. And an HA. VA, we set it equal to 0, the denominator, x equals what? 0. HA, is there anything here? No, so it's still 0. All right. Now, being that it's a parent function and it has a square on the denominator, the graph is here, negative 1, 1, a J, and 1, 1, and an L. However, look up. What if I only wanted this to show? Look up, please. What if I just wanted to see that portion of the graph? Tell your neighbor what would you write for the domain? What would you write for the domain? All right? What do we write for the domain, Edwin? The negative 2.5, yes, and positive 2. So that means we're only going to see from here to here and from here to here. Nothing on the outside because that is not Good morning, Mr.Q. Yes, I'll send him. Thank you. Okay. All right. Thank you. Clarissa, Frida, going home. So we will see the arrows going upward, but not anything going to the left or to the right because it stops at 2 and 2. All right. So with that said, open your Chromebooks, please. All right. So in Desmos.com, you are here. From there, oh, Frida, you're also going home. Oh, okay. And then open up where it says here, open graph calculator. All right. All right, y'all ready? All right, here it goes. So, we're going to start by graphing the parent function x squared. So, instead of using f of x, let's use the letter y. So, y equals, type in x. Turn off the light, Edwin, please. type in X, then go to this up arrow right here for the keyboard, and then go to the a squared. There you go. So here's the parent function, f of x equals x squared. You guys see it? Yes? However, look up. What if I only wanted for you to show me from, let's see, from here to there? Does everybody see that? From here to there. So, tell your neighbor, what would you write right here? Bracket. What? What would you write from there to there? Talk to the neighbor. What would you write from there to there? All right, Gabriel, what do I write? -1. And then go here to the menu, less than or equal to x, less than or equal to what? Gabriel? 1. Close bracket. There it is. How we doing? Yes? Now, let me show you a couple things that you should know. Look up. Let's say I wanted to add color to this or change the color. So you go back to it, click on the gear button right here. Click on that. Then you're going to click on the color dot and change the color to a different color. Let's say I wanted to choose purple. And I wanted the line to be thicker. Look up. Go here to the second line and type in, let's say, a 5. There it is. How are we doing? All right. But what if, Mr. Q, what if I wanted to shade upward from that parabola? Look up. Go here to the equal sign. The equal sign, highlight that, and change it to greater than or equal to. And you're like, well, what if I did less than or equal to, Mr. Q? We'll change that to less than or equal to. Let's say you didn't want to color it, then just go to the original and change it to equal. How we doing? All right, next. Turn that button off right here where the little color thing, click it. And let's go to the second row. We're going to type in another function. Go y equals, let's start with the parentheses. Let's do parentheses, x, close parentheses, squared, plus, parentheses, y, close parentheses, squared, equal to 1. And that's a circle. I want you to change the color of the circumference. How do we do that? Again, go to the gear, click on the color, and change the color. Make it thicker. I'm going to do a 5 again. However, tell your neighbor what to do to shade the inside of the circle. What do you change to shade the inside of the circle? Yeah, change the equal sign to less than or equal to. But what if we wanted to shade the outside of the circle? Change that to greater than or equal to. How we doing? Let's change it back to equal. However, right now the radius is what? 1 in each direction, yes? So that means to make it bigger, tell your neighbor what to change on that equation. What do we change on that equation to make that circle bigger? What do we change, Mario? The 1 to what? Give me a number. 3. And so on and so forth. All right? How we doing? Okay, this time, look up. I want you to turn on the other one. Let's say I wanted this original one, the purple one of mine. I don't know what color it's on yours. I want you to move that so it can be up here, right above the circle. What do we need to change to this equation? What do we need to change on that equation to move this one right above here of the circle? Talk to your neighbor. What do I need to change on this equation to move this original one up there? What do I need to change, Sean? The domain is the same width from -1 to 1, but I need to move it upward over here, from here. +1. Not quite. I need to move it up here. +2. All right, not bad. And so on and so forth. All right, turn these off. Let's do one more. Y equals. Let's do 1. Then go to the divided by x. There it is. However, I don't want anything to the left of -2 or anything to the right of +2. So tell your neighbor what to write for the domain right there. What do I write for the domain? Bracket -2 less than or equal to x less than or equal to 2. Close bracket. There you go. Isn't that cool? Pretty good, yeah? However, look up. Question. So I don't want anything from the left of -2 and the right of -2. However, what if I also wanted you only to show me from -2 of y to +2 of y? Nothing after 2, nothing below -2. What would we write right after that? Talk to the neighbor. What would we write right after that? Bracket what? Elijah, what would I write? -2, very good. Less than or equal to y. Less than or equal to +2. Close bracket. And now you're only showing me these little pieces because I cut everything above the 2 of y, everything below the 2 of y, everything to the left of -2, and negative to the right of -2 of x. Turn on the other one, see how that looks. How we doing? Not bad, yeah? Okay. So, with that said, I'm going to give you a little bit more time. I want you to add one more function. I already have a quadratic. I have a circle. I have a rational. Add a cubic and see what it does, and then do a domain for that one. Change the color. Y equals X. Look up. To put the cubic, you go to this one that says A with exponent B, this one right here, and then type in the number 3. I'm going to change the color. Go to the gear. I'm going to change that to an orange, and I'm going to make that a 7, a little bit thicker. There it is. And so on and so forth. You get the idea, yeah? All right. So, now that I gave you plenty of time working with this for right now, set it aside. Get your graph paper in front of you. Turn it over to the blank side. And I want you to sketch me something simple. Look, like me, I can sketch something simple like this. That's pretty simple, yes? And if I want to add a little bit more, then I would do sketch something on the back side of yours, something simple, and then show it to your neighbor. Something very simple, very simple. All right. Now, if I was to take a wild guess and I pick Mario, I'm assuming he's going to write MG. Very original. Did you write MG? 2? Like that? Okay. All right. Anyway, show your artwork to your neighbor. All right. So, simple artwork. So this is your task for tonight. You're going to go home. You're going to open Desmos, graph, and you're going to sketch that using functions. You already have examples of them right there in front of you. So whatever you sketch, create it on Desmos. You don't have to finish it as long as you put some time into it. And then I want to see that work tomorrow as you walk in. Now, some of you still need to turn in your binders. Tomorrow I'm going to pick those up as I get you guys started with the next part of the project. So make sure you bring your binders ready. Stop right there. Those of you following on YouTube, make sure you get some practice in. See you guys next time. Peace.